Welcome back for another tutorial in Mastercam. This one here, we are going to go over Lathe C&Y Axis Exercise 1 handout. So this is going to be the handout that you'd find under your assignments on the portal. You'll notice here, if just taking a look at this print, that we have some new features here. Actually, I guess just one new feature because we still have a square on the back side here. You can see. This this isometric drawing doesn't do it really much justice because of how dark it is. But we also have a cross hole feature, and then the new features are going to be these face drills. So we're going to add some face drills here. So let's get started. So let's go ahead and, as normal, go to our machine and select our machine. I'm going to select Handout 4-axis. Again, if you don't have Handout 4-axis, default here is fine, so you can use default. The next thing I'm going to do is go to my planes, like always, and hit equals, and go to top, and I am ready to draw my part. So let's go ahead and get started. So just looking at this real quick, it looks like we have pretty much an easy part to draw here. So I am just going to start. I'm going to draw this whole thing. I'm going to add these grooves in later, and then I'll trim those out. So let's start with a line, multi-line, 0, 0, start point. And then we're going to 1.5, 0, enter. And then it looks like negative, 1.5, negative 3.0, enter. And now we get to, let me check out that quick. And now we get to a point where basically it's not giving us this diameter. Now we know that it's 2 inches across the flats, but the turn diameter is going to need to be a little bit bigger than that. It's going to be across these corners. And we don't have a dimension for that. So the easiest way that I've always found to do something like this in Mastercam is just to go ahead and draw that feature, measure it, and then we'll create the profile, the rest of our lathe profile, our turn profile for the part. So let's go ahead and draw that square with the radii on it at negative 3 inches where it begins. All right, so first thing I'm going to do is go to a different plane. I'm going to go to my right plane for this and just go to right. Right. Oops, am I in the wrong plane? Top. Oh, yeah, because I hit right. When I select the right plane, I just made a little bit of an error there. So when I select the right plane, I want to pick top because then it's going to put me on the right plane. If I pick right, then it's going to put me on the right plane from the top, which would be this side. So you have to select top there. Okay, so we're going to draw a rectangle, and let's make this, it's going to be at 0, 0, I believe it's negative 3.0, enter. And we're going to make this 2.0, tab, 2.0, enter. Check. Okay, so there is our square. Now we just need to put some radii on this. So I'm going to pick the fillet chains, chain that, and we're going to put 0.5 on there and hit check. Okay, so there is our square. Now all I have to do is measure across this. So I'm just going to go to drafting. I should be able to use smart dimension for this. And I want to get my node points. So there I got 2.414. Okay, so I'm going to make this, like I did last time, I'm actually going to add a little bit to the diameter just so that I know that it mills the whole thing when I go to mill it. So I'm going to make this 2.4, let's say 2.45, 2.425 I'll make it. That's 10 thou. All right, so 2.425. So we're going to go back to our DZ plane, equals, go to top. And select my line, and I go 2.425, negative 3, enter, and then I'm going to go 2.425, negative 4.0, and that is the back of our part. Okay. So there is our profile, and then we already have our square in there as well. The next thing that we are going to work on, let's go ahead and I could have put these face holes in there while I was on that plane. Just didn't do it because I was too focused on showing you how to find that diameter there. But let's go ahead and add this through hole while we're here on this plane. Okay, so this through hole, by the way. This through hole, if you look at this, it could either be drawn right here on center, or I could actually just draw it up top. There's no difference between orientation. The part is symmetrical that way. I'm going to show you how to draw it the way that they have it, but you could just draw it right up here at the top of the profile. So I'm going to go ahead and hit a point. And my point position is going to be at a diameter of 0, comma, and I'm going to want to put in a y-axis, and that is going to be a positive 0.75, comma, because it's half of the diameter, and negative 1.5. Enter. And there is our point. So if you take a look at that point, okay, so that one's in the center there. We actually want to bring that up in the Y. So let's go ahead and delete that. And let's actually work on a top plane for this. Let's go to top, and let's go to X is going to be negative 1.5, comma, Y is going to be 0, comma, and this time we're going to have the Z coming towards me. It's going to be 0.75, enter. Okay. Yes, didn't take in the DZ plane, but it took here. So there we go. So if you draw that in the top plane, you can get that point exactly where you want it. All right, so we have our point. Next, we'll go to our right side, and let's put those holes. Actually, no. Let's finish this profile. Let's put these grooves in it. Okay, so it looks like we have 1/4 inch wide grooves. So what I'm going to do is I'm actually just going to draw squares and trim them. So I'm going to draw a center point square, and I'm going to center it in between these two dimensions, which is going to be negative 0.875. And I'll draw it right at the 1.5 inch, and I'll just drag it down and make it the correct size. So let's take a look here. So by the appearance of this, by the way, it looks like this is 0.3. So half of that would be, the difference between these two is 0.3. So half of that would be the depth, which is 0.15. So let's go ahead and draw a rectangle. We're going to anchor it to the center. I'm going to put it, before I do that, let's go to planes and let's work on the DZ plane again so that our coordinates are correct. And I'm going to put this at 1.5, comma, negative 0.875, enter. So there is my groove. And now I'm just going to put the width at, looks like that is a 1/4 inch, 0.25. And it looks like our depth is 0.15. So I'm going to make that 0.3. 0.3 for our height. And hit check. And there we go. Now do one more. And that one is going to be located at, it looks like 2 1/8. So I'm going to go 1.5, comma, negative 2.125. And again, our width is 0.25 and 0.3 is our height. Hit check and divide. There we go. Check. And there are our grooves. So if we measure these, they should be 150 thousandths deep. So let's just do that real quick. Let's take a quick measurement and just see what we get here. And there we go, 150 thousandths. So they look good. Next thing we can do is we can go ahead and work on them face holes. So let's hit equals, work on the right side plane, hit top. And it looks like we have a hole pattern of 4 holes. And I'm actually going to draw the holes rather than points for this. The hole pattern appears to have a radius of 0.75. So I'm going to go ahead and draw a circle at 0.75. Enter. Actually, check that. It's a radius of 0.75. I meant a point at 0.375. I have to put the radius in there, not the diameter. My mistake. Next, and you notice, I noticed that was wrong right away because I could tell it was way out here where the center point was. So it was pretty obvious that it wasn't in the right place. So that's one of the things you got to watch out for in these. You want to make sure that you're kind of being attentive and seeing, does it look the way it's supposed to look. Let's see here. So our diameter of those holes are 0.25. Okay, check that one. And then we also have another one, which is the countersink, which is a radius of 0.175. So we'll just add that in the radius, 0.175, enter, hit check. And then let's rotate these around. So let's transform, rotate, and let's do 4 around a 360. Actually, let's just do 90. 90 between, and let's do 3. There we go. That way we're not overwriting that one. So there are our holes. Check. And there we go. So looks pretty good. All right, so we are ready to turn this profile. All right, so let's go back to the DZ plane, equals, and go to top, and toolpaths. All right, I'm going to go to turning, and I'm just going to select my turning profile here. Well, first, actually, before we do anything, we better set up our stock. So stock, DZ plane, properties, everything here looks pretty good. We need to change our stock size, and I forget exactly what that was, so I need to measure. Let's go to drafting, and let's see. Oops. Bear with me here. Smart dimension. There it is. That's the point that I want. I was accidentally grabbing those holes. All right, so we got 1.2. So let's say it's 1 1/4. That's 2 1/2. So 2 1/2 should clean this up. All right, so let's use 2 1/2 inch stock. So I go pick my stock size, and I'm going to go ahead and pick 2.5 diameter. Length, 4 inches. I believe this part is exactly 4 inches long, so that should be fine. And of course we have a 2-inch margin, so everything there looks pretty good. So I'm going to hit check, check, and hit top. All right, so this looks good. We have some material to take off here, and this part should come out of this just fine. All right, so let's go back to our turning tool, or turning tool paths. Hit face. Of course, speeds and speeds need to be set correctly. I have a library set up, which is really nice for stuff like this. So I'm just going to select my aluminum tools. Open. Filter. Oh, I don't think I put anything in those yet. So let me go back to my steel tools. Steel tools are where I have some stuff. Thought I had that set up, but I do not. Steel tools, open. Okay, there we go. All right, so I'm going to go ahead and select my OD rough. Tool 1. Change my speeds and feeds. It doesn't seem to be picking it up. So I'm just going to change it manually. 900, or maybe it's aluminum, so let's say 2000. I'm going to have to change it anyway because I was picking steel tools. Okay, so all of this stuff looks good. Computer looks good. Hit check. All right, there's our face. Okay, next path, I'm going to pick my rough. And I'm going to go ahead and select here and hit check. Oh, see, now I got my speeds and feeds. It's weird how they don't pop up that first time. I still need to change it anyway, though. So I need to go 2000. Just because it's aluminum, I'm doing that. Honestly, if you leave it at 900, just as long as you've changed your speeds and feeds just to make sure that you're doing that, get in the habit of that, that's fine. Everything in here is good. I have all this stuff set up, obviously. My lead in should be extended. Yeah, my lead out, should be extended. Everything here is good. Use stock for outer boundary. Hit check. Finish. Just pick last. Hit check. And I'm just going to use that same tool. Check. All right, that all looks good. So the next thing I can do is groove this, but I'm probably going to wait till last to do that since I use pretty much the same cutter to groove this as I do to cut it off. So I'll do that last. Next thing I'm going to do here, I believe, is I'll probably drill these holes on the end. And then I may do this one, and then I'll do this back profile here. So to do these holes on the end, what we're going to do is we're going to select a face drill, and I'm just going to select my points. Now remember, you have a depth filter, so you have to turn that off if you want to be able to easily select these points. Okay, and I'm going to hit check. Tool. Of course, I'm going to go out to find a tool, and I'm going to say none. And I am not going to, or actually I am going to spot drill this because I'm going to put my chamfers on with the spot drill. Let's see here. We have a drill. Not sure if we have spot, yeah, there we go, spot drill, check. And let's go to the correct lathe drills. None in there, so let's go to lathe tools. Lathe inch. See, we have them. There we go. Okay. Now what I'm going to do is I'm just going to look at my spot size. So it's a 0.175. So that's basically 350 thousandths is what we end up with there for a diameter. So I can get away with actually a 3/8 spot drill for this and still create that diameter. So I don't have a 3/8, so I'll just use a 1/2 inch. That's no problem. Hit check. Okay, feed rate, we're going to make that about 8.0. Spindle speed is, we'll make that about 1500. Drill counterbore is fine. Linking parameters. Okay. So, if you remember correctly, basically we go half our diameter for the depth to create a diameter. So I am just going to go a little bit less than that because remember for the flat on the tip of our drill bit. So I'm just going to go negative point. Actually, I'm just going to go the radius because for the sake of, if I was actually making this part, I would reduce this number and then I would walk it in to get it to where I need it. But since I'm not making it, it's just for simulation here. So I'm just going to go with it. So negative 0.175 and hit check. Okay, so there is our spot drill. All right, next thing we're going to do is drill these. And don't be alarmed by these circles here. That's just showing the diameter of the spot drill. It's not necessarily how, that's not how big that diameter is going to be at the bottom of there. So, and if it is, we'll fix that. So let's just let's get them drilled, and then we'll take a look and see what we've got there. But I'm pretty confident that's not the case. Okay, select them all again. Check. Face drill. Select tool from library. Okay, this time we are going to select a regular drill. And looks like we need a 1/4 inch drill for this. So it should be up here somewhere. There it is, 1/4 inch drill. Feed it 8.0. And we'll say this thing's running at, again, 1500. I don't like to run these too fast. There's no reason to run a drill super fast in this. We're not drilling deep or anything like that. It's not like we have, you know, a deep hole that we have to drill out. So it's not really a big deal. So I'm going to go ahead. It's only a 1/2 inch deep. So I'm going to put -0.5, and I'm going to calculate my tip, which is 118 degrees. Finish diameter is 1/4 inch. And looks like our calculation to add for our drill tip compensation is 75 thousandths. So I'm going to add that to it. And I'm just going to go ahead and hit check. And there is our drills. All right, now let's go check this out by simulating. Just see how this looks. Simulation came up on the other screen. Okay, take a look at that. Looks perfect. So everything there looks great. Awesome. Okay, so we are now ready to drill our hole through the part. So let's go ahead and do that. We're just going to use a cross drill. I usually use cross drill when I'm drilling through. And I'll use a C-axis drill when I'm just drilling holes around the outside. This will also drill off center. So I'm going to go ahead and hit my cross drill, select my hole, check. And it looks like that hole as well is a 1/4 inch. And it says it's through the entire part. So I'm going to select my, I should spot drill this because this thing is going to want to walk because it's on the outside of a diameter. So I'm going to go ahead and hit 5.0 and run this at about 1500. Cut parameters, drill counter bore is good. Our depth, we are going to make that 0.26, or sorry, I'm going to make it half of 0.26, which is 0.13. And it's just going to put a little chamfer around the outside. It probably won't even clean up the whole outside, but I could adjust that if I wanted to make sure that it chamfered the whole outside of that. I'm going to go ahead and hit check. And there is that. I'm going to pick it again. And this time I'm going to drill it. I'm going to pick my drill, 8.0 at 1500. And my depth is going to be all the way through. So I'm going to go, it's 1.5 inch part. So I'm going to go at least -1.5. I'm actually just going to make it -1.6 just to go through. I'm going to hit check. All right, let's regenerate that and let's play that. So there we go. Looks pretty good. Doesn't really show up that that chamfer I want to put on. I'd probably have to go a little bit deeper. So let's just because of the fact that it's on the outside of a part here. So let's take that a little deeper, see what happens here. See if we can get that to work for us, that spot drill. Oh, that's why, because I'm going to a positive, negative. So oftentimes I'll do that. If I do that, it's obviously by accident. Forget to put my negative sign in. So there you're seeing a little bit of a chamfer on the outside of there. So we'd need to take that a little deeper if we wanted to chamfer the whole thing. So let's go ahead and do that. Why not? So let's go to spot. Let's take it to -0.14. Take an extra 10. See what that gives us. That might be a little too much. Maybe we'll back that off. I'm not sure. Oh no, that actually looks good. So it's smaller right there. You want to make sure it cleans up the whole way. That looks good. Very nice. Now I could do that to the other side of the part as well. I just have to draw myself another point there. So I could do that. In fact, I'm actually going to, just to make this part complete. So I'll just go to planes, go back to my top plane, because that's how I created this point. And I'll just go to wireframe, create a point. And that point appears to be at negative 1.5 in the x, comma. And the last one was positive 0.75. I'm going to go to negative 0.75, comma. Oh, no, actually, sorry, 0 in the y. 0, comma, negative 0.75 in the x, or in the z. Enter. Okay, and now we have a point back here as well. Now it's only drilling past that because, remember, I just added a bunch of extra. I added 100 thousandths extra for my drill just to make sure it goes through. We go back to turning, do our cross drill, select that point. And I could do C drill too, but I'm just going to stay consistent. Go to tool, or spot, feed rate 5.0 at 1500. Cut parameters, it's fine. And this was, I think we said negative 0.14, if I'm not mistaken. And go ahead and hit check. And let's see what we get there. Chamfered, chamfered. So they look nice. That chamfer should look the same as this chamfer, and it does. So our hole is chamfered on both sides. These holes here are chamfered. This edge here, we could add a chamfer to that. I would just probably draw it in if I were putting a chamfer on it. We're not going to worry about it at this moment. I just wanted to demo chamfering those holes. All right, so let's go ahead and move on to doing this outside face profile. Okay, so we can go to face contour, and we're going to go ahead and select that. And this is going to be a climb mill. And I'm going to actually dynamically make that to the center there. Actually, no. I'm going to dynamically make that to here. I'm arguing with myself internally where I want to put it. I'm going to put it over there. Let's see, we're going to go to use an end mill. Just going to use this end mill, check. And let's see what we have here. All right, so this is way back in the Z. This is 4 inches deep. So this is not really a realistic way of doing this. We would probably hand this off maybe in a sub spindle or something like that and mill the backside, flip it and mill this side. But the way the tutorial wants us to do it, we're just going to do it, with a really big end mill. So I'm just going to pick a 1-inch end mill because we need something big that's going to hang out 4 inches. So I'm going to pick 1 inch, and we're going to feed this at about 30 inches a minute at a spindle speed of 5,000. Plunge rate is 20.0. Whoops, 20.0. Okay, and we're going to need compensation. Compensation should be off to the left. And we're going to put it on where. This is a 2D contour. Everything we're leaving no material on. Depth cuts. We're not going to take depth cuts. We're going to take this all at once. We're going to lead in though. And make this 10. This 10. And copy all that over. Multi-passes, we're going to turn that on. We're going to make at least 3 rough passes at a spacing of 0.1. And we're going to do a finish pass at a spacing of 0.005. Okay, linking parameters, our depth. We'll just select the back side here. I think it's negative 4 inches anyway. So it's negative 1 inch incrementally from where we are at currently. Remember, all these are incremental, so that's why my numbers are okay there. I'm actually going to bring this a little bit deeper. So I'm going to make it 1.05, just so I know it goes past. Check. And there is our path. So let's see how that looks. Let's see how our roughing paths look. We won't need to add one or two. Not sure. Okay, no, it looks pretty good, with the exception of the fact that our holder is plunging into the part there. And this is exactly what I meant by you need a really long tool. It's not realistic to do it this way. It's just not. But this brings up a good thing here. So we can take a look and we can actually alter this tool. So let's go in and click on our tool. And we bring our tool up. And let's take a look here. Overall length, let's make that 6.0. Oops, not 60. Let's make it 6 inches. Cutting length, 2 inches is fine. Diameter is fine. Okay. So let's go ahead and hit finish. And let's re-simulate that. Okay, so we're still in there. I just need to make it stick out of the tool farther, or out of the holder farther. I wasn't sure if it would automatically do that for me or not, but it did not. Okay, so here, length offset, geometry, here it is. Okay, so shoulder diameter, here it is, 2.5 shoulder length, cutting length. Let's make this 4.25. All right, finish. Let's regen that. Hit play. All right, so there we go. All right, so it looks pretty good. And if I wanted to, I could put a chamfer mill in and chamfer, around that edge, do the same thing. But I believe I'm ready to do my grooves. So I'm going to go ahead and hit top. And I think I'm in the YX. I'm just going to go back to my plane. I really don't need to be back in the ZZ plane, but I'm going to go back into it anyway. It doesn't really make a difference because I'm not drawing anything. All right, so let's go to our groove, and let's groove these. Chain this. Oh, chain. Reverse. Enter. Stock is outer boundary. I think everything in here is set correctly. Yeah. So hit check. And let's do that again. Check. Okay. Both our grooves look good, and now we're ready to cut this thing off. Let me go ahead and pick cut off. Pick my back side. And of course, we're going to use this grooving tool. Now, we might run into an issue with clearance on this. We'll see. I think we will. I am not going to put a chamfer. There's no need to, because you're only going to chamfer the corners of this thing. So I'm just going to turn that off. That's not really going to do anything. So you'd have to do some kind of second operation to deburr this one. So I'm going to check. And let's go ahead and simulate that. Yep. So yeah, you can see there we cut quite a bit into there trying to cut this thing off. Okay, so what I'm going to do here is, obviously our tool wouldn't really look like that as a cutoff. We use the blades. So I'm going to just go into my grooving tool, and I'm going to go to holder, and I'm going to go ahead and just extend this C value. So I think we're cutting off 2.5 material. I'm just going to make this, 1.3 or something like that. Something that I know it's going to be long enough. Yes, I want to update my operations, and let's go ahead and take a look at that now. These are the things that you should update just so you can get a good simulation. And there we go. So that looks good. You can see our line all the way around the part, so we've cut it to size. Our holes line up perfectly with these diameters that we drew. Everything there looks great. And then we even deburred these holes. So that is basically it for this tutorial. Again, as always, if you have any questions, feel free to see me during class, or of course you can see me during my office hours.